family. In today's lecture we are solving out the question related to the differential equation. The question says that solve the differential equation d square minus 3d plus 2 into y is equal to e the power x. Solution. Solution. At first write down given equation is given equation is d square minus 3d plus 2 d square minus 3d plus 2 into y is equal to e the power x. Now auxiliary equation is given by now auxiliary equation in short form we can write down AE is given by for finding out the auxiliary equation we put capital D is equal to M. We put capital D is equal to M and it is equal to 0. Then we get M square minus 3M plus 2 is equal to 0. 2 is equal to 0. Now by the splitting of middle term we solve out a quadratic equation and get the roots. M square minus 2M minus M plus 2 is equal to 0. Take out M as a common and solve out. Then we get M. M is common, then M minus 2. Again minus 1 is common, then M minus 2 is equal to 0. We get two roots. First is two factorial M minus 2 M minus 1 is equal to 0. When we take 1 by 1 equal to 0, we get two roots. First one is M is equal to 2 and second is M is equal to 1. M is equal to 2 and 1. Now CF is given by here. Hence CF is equal to, we know that when two roots are unequal then CF is equal to C1 e the power ax plus C2 e the power bx. C1 e the power x plus C2 e the power 2x. This is the CF. Now Pi is equal to, Pi is equal to, for finding out the Pi, write down the RHS part in numerator, that is e the power x, and the equation of differential equation in the denominator d square minus 3d plus 2 d square minus 3d plus 2. Now by the identity we know that if e the power ax upon fd is given upon fd is given, then we can write down e the power ax upon fa. Fa stands for function of a. In this, we replaced capital D is equal to a. When we put here the value of a is 1, when we put 1 the square minus 3 into 1 plus 2, that is 0, so it is not possible. Then pi is equal to e the power x upon d square minus 3, d2 plus 2 is the factor is m minus 2, m minus 1, so d minus 2 and d minus 1. When we operate the identity, it becomes pi is equal to e the power x as it is. Here the value of a is 1, so put the 1 where it is possible. 1 minus 2 and it becomes d minus 1 as it is, because when p put 1 minus 1 is 0, in denominator not possible. Now we again operate the identity. Identity says that if e the power ax is given and in denominator d minus a the power n is given, then solution is x the power n upon factorial n into e the power ax. This is the final solution. Now pi is equal to, e the power x minus e the power x minus e the power x, because 1 minus 2 is minus 1, so e the power minus x. D minus 1 is d minus 1 the power n, so we can write down d minus 1 the power 1. The final solution is given by pi is equal to x the minus as it is x the power n, x the power 1 upon factorial 1 into e the power ax, e the power x. So pi is equal to minus x into e the power x. Now general solution is given by, hence general solution is y is equal to CF stands for complementary function plus pi stands for particular integral. So y is equal to CF is c1 e the power x plus c2 e the power 2x. c1 e the power x plus c2 e the power 2x minus x into e the power x. It's our final solution. I think you understand how we can solve out the given question by the using OP identities. Hence the general solution is CF plus PI. Now we can solve out the given question by using OP identities and finding out the auxiliary roots. Now our lecture is finished. Jai Hind, Jai Bharat.